In this video, we'll find the distance from a point to a line. So, before we dive in and do the specific example, let's maybe figure out what the formula is in general. And then at the end, we'll just plug in the information from this example and get our answer pretty quickly. So, let's start by drawing a picture. So here's our point P not on the line, and here's our line. I guess in this example, given by a vector function r of t. Now here's what we want. We want this distance right here, which is the length of this line segment, which goes from P and meets the line orthogonally. So I'm going to call it D in the picture. That's what we want to find. Okay, so we need sort of two other pieces of information before we go on and figure this out. One, we need to give a name to the direction vector of the line. So V will just be some vector which is parallel to the line. Second, we need any random point on the line. We can pick any point we want. In my picture, I'm going to draw it here and call it R. And just to emphasize, I'll write it. Any point on the line. So you might start to think maybe we can use some sort of trigonometry. It almost looks like there's a right triangle here. Just haven't drawn the hypotenuse, so let's draw it. And let's draw it as a vector. So this would be the vector RP. It starts at R and ends at P. Then, by sort of basic trigonometry, we can see that if we call this angle here theta, then the distance we want, since it's the side opposite theta, is the length of the hypotenuse times the sine of theta. I'm going to call this equation 1 for now. Now, as it stands, this isn't super useful because we don't know what theta is, because we just picked a random point r. But we can sort of get around that by doing something clever. We can remember the formula for the length of the cross product of two vectors. Now, if you'll remember, the length of the cross product of two vectors is the product of the lengths of those vectors times the sine of the angle between them. Now in the picture, notice that theta is the angle between the vector RP and the vector that I called V. So using that formula for the length of the cross product, we can say that the length of the cross product of RP and V is the product of their lengths times the sine of the angle between them. And that angle is theta in this picture. And now what you should notice is that in these two equations, the right-hand sides are almost exactly the same. The one on the top, equation 1, is just missing the length of V. So let's take equation 2 and maybe divide everything by the length of V. And now the right-hand side is the same as the right-hand side of equation 1. And so this expression here is actually equal to D, which is what we were looking for. And so that's it. This is our formula. Now we need to go back to the example we were given and plug everything into this formula. So let's start writing down all of our information. So we're given at the beginning that P is the point 1 minus 6 is 0. And R I said is any old random point on the line. So we get to choose what R is. You can pick any point you want. Now since r is given by this vector equation, r of t, maybe just to keep things simple, let's just plug in t equals 0 and use that as our point r. So you can see if you plug in t equals 0, you get the point minus 2, minus 2, 4. Okay. Now what? Well, we need the vector rp, so just subtract. So we get 3 minus 4 minus 4. Okay, what else do we need? We need the vector v. So maybe let's go back up to the top and look at our equation for r of t, and let's rewrite it a little different. Let's separate the constant terms and the terms that have t. So we have negative 2, 4 are the constant terms, plus t times 3, 1, minus 1. And so this is our vector v in this example. So for us here, v we can take to be the vector 3, 1, minus 1. Okay, well, we also need a couple more things. We need the length of this vector, which we can easily see is the square root of 11. And we need the cross product of this with rp. And if you compute this, you will get that the cross product is 8 minus 9, 15. And last thing we need is the length of this, which comes out to be the square root of 370. So now we have everything we need. If we look back at our formula that we came up with, we just need these two things. The length of rp cross v, and the length of v itself. And we just divide these two things. So our final answer is that the distance between the point and the line is the square root of 370 over the square root of 11. Or if you like, put it all under one square root of 370 over 11.